So let's continue on. Let's go ahead and do the exploration on page 133. Compositions with absolute value. So in this one, they give you an interesting task, and you have a parabola. It looks like this. And so this is y is equal to f of x. And in A, they want you to find the y is equal to absolute value of f of x. Well, this one's pretty simple, right? Because all you're doing is you're taking whatever's, so if y was negative, right, you're going to go ahead and move that, flip that over, right? So your end result is going to look like this. So this would be your graph, right? So it looks like this. And is there one that looks like that? Which one would that be? That would be C. So that would be C, okay? So that's C. That one's, like I said, not too complicated. So what I'm doing is flipping over the negative part like that, all right? So now let's see if we can go back and start with the original one. Okay, and 2 was, now you're taking the, not this, but you are doing f of like that. So this is, can be a little, so let's go ahead and see if we can logically work this through. So f of 1, or f of negative 1, what is, when x is equal to negative 1, what do I get? When x is equal to negative 1, right? This is going to be what? This is going to be the same as f of negative 1, which is what? Since this is 1, the same as f of 1, right? So f of 1 was what? When f of 1 was, is that about 1 in the original graph? Yeah, somewhere around here is about 1. So this guy here is f of 1, and that's going to be the same as negative 1. When negative 1, I'm going to get that guy here, okay? In other words, I'm going to go like this and like that, okay? Because when f is 2 or negative 2, I'm going to get the same value of f of 2. When f is negative 3, I'm going to get the, when x is negative 3, I'm going to get the same value of x is 3 when x is equal to 3, which is up here, okay? So in other words, I cut this guy off and I reflected it across, okay? Do you have anything that looks like that? Looks like it's A. Looks like it's A. So before we move on, let's go ahead and do 4 first. What do I have in 4? 4, I'm taking this guy, and now I'm just going to go ahead and go like that. So I'm going to start with this guy. And since I put the absolute value on everything, basically whenever y is negative, I'm going to flop it over. So it's going to look like that. Okay. And so that would be, looks like it's D. Okay. And then number 3. Number 3 was basically taking 1. What did I do? So let's start with 1. Let's go back to 1. Number 1 was, I think we said it was C. So it's going to look like, I'm going to start with this because this is what? This is y is equal to that. And the question asks not what is this, what is that? What is a negative, right? Which means that basically what we do is wherever y was, I put negative y, which means what? Wherever y is, I put negative y, which means it's a reflection across the x-axis, right? So I'm going to reflect this guy across the x-axis, so it's going to look like that. And so that would be F. Okay? So you see, this is kind of interesting. This is an interesting question because you have to use all your knowledge here on how these things work, the reflection across the x-axis, the y-axis, and also you have to combine the, how does the actually absolute value work, right? Interesting exploration there. Okay, so let's move on. Let's go to stretches and shrinks. So now we are not going to do, we're not just going to stop at translation, meaning keeping the same shape and moving it around. We are actually going to start monkeying with the shape itself. Okay, so we're going to stretch things and shrink things. So in other words, I can start with something that looks like y is equal to x squared. And I can vertically stretch it, meaning it would be more pronounced like that, or I can vertically stretch it, or I can vertically shrink it, meaning that I'm compressing it. So it's going to look like this, it would look like this, right? The purple one here, right? Or I can just do the same concept, I can actually do a horizontal shrink or vertical or stretch, right? So horizontally, right, I can stretch it. Horizontally, I can stretch it. So this was vertical here. This is horizontal here. I can horizontally stretch it, or I can vertically or horizontally, I can shrink it, okay? So again, the reason why it's a horizontal shrink is because horizontally speaking, I shrunk it, okay? So there'll be some functions like this that a horizontal shrink can be the same as a vertical stretch, and a vertical shrink can be a horizontal stretch, but not all functions are that way. So don't go to get into the habit of thinking that one equals to the other one, okay? It works sometimes, sometimes it doesn't, okay? All right, so the way we do this is on page 134, there's a blue box there that says stretches and shrinks of graphs. Again, horizontally, it makes sense. Horizontally, if you're going to stretch by a factor of c, it's wherever x is, you put x divided by c. When you shrink by a factor of c, but if it's less than 1, then it becomes the other way around. So that's fine, okay? Now the same thing that we've done so far on each blue box is going to apply to this one too, where it says y is equal to c f of x. Don't think of it that way. Again, where y is, you're putting y over c. Where y is, you're going to put y over c, and it's going to be f of x. So the c is going to go over that way, okay? Again, this is going to make it much easier for you, okay? When you're stretching, you're going to put y over c. When you're shrinking, it's the same way, but the factor is less than 1, okay? All right. Okay, so let's see if we can do that. Let's see if we can do example number 5. Let's see if we can do example number 5. Example 5, let C1 be the curve divided by that. Find the equation for the following non-rigid transformations. In other words, following that are not translations. So y1 is equal to f of x, x cubed minus 16x. Okay, a vertical stretch of C by a factor of 3, a vertical stretch. So this is in the y direction, right? So wherever y is, I'm going to go like this. So where y is, I'm going to put y over 3. So the end result is y is equal to 3 times x cubed minus 16x. Okay, so that was A. Let's go to B. Horizontal shrink of a factor of c by a factor of 1/2. Horizontal shrink. So where x is on this one, so this was this one or A, what was it? A. So it's A, and now we'll do B, and in B, we'll do a horizontal shrink by a factor of 1/2. So wherever x is, I'm going to put x over 1/2 cubed minus 16 x over 1/2, looks like that. So it's going to be 2x cubed minus 16 2x. It's going to be 8x cubed minus 32x. Okay, so that's how you do that. Now on page 135, we're talking about combining transformations, okay? Combining transformations. When you're combining transformations, you have to be very careful of the order in which you do the transformations. You can have the same 3 steps of transformations, and if you do them out of order, you'll come up with different answers, okay? So example number 6, the graph is y equals to x squared and goes to find results. So we're going to start with y is equal to x squared. First one is a horizontal shift of 2 to the right. So if I move this 2 to the right, it's going to be what? Where x is, I'm going to put x minus 2. Okay. Then a vertical stretch by a factor of 3. Vertically, I'm going to stretch it by 3. So wherever y was, I'm going to put y over 3. So you're going to end up with 3x minus 2 squared. Then last but not least, it says a vertical translation of 5 up. Going 5 up, so where y is, I'm going to put y minus 5. So if I do this out, I'm going to get what? This is going to be 3x squared minus 4x plus 4. I'm going to get 3x squared minus 12x plus 12. Now I'm going to move the 5 over. So I'm going to end up with, instead of 12, I get 17. So this is my final answer. That was in A, okay? Now let's do B. And in B, it says apply the transfer A in the opposite order and see what happens. So now we're going to do an opposite order. Again, we're going to start with this. Y is equal to x squared. Opposite order, we're going to do the bottom one first. A vertical translation of 5 units up. So wherever y is, I'm going to put y minus 5. So y is going to be equal to x squared plus 5. That's the first step. Second step is a vertical stretch by a factor of 3. So wherever y is, I'm going to put y over 3. So y is going to be equal to 3x cubed plus 5, which is 3x cubed plus 15. Then the last step is a horizontal shift of 2 to the right. So I'm going to move it 2 to the right. So it's going to be y is equal to 3x minus 2 cubed plus 15, right? And you can already see, whoa, this is not cubed, this is squared. Squared, this was squared, so I'm going to get 3x squared minus 4x plus 4 plus 15, 3x squared minus 12x plus 12 plus 15, 3x squared minus 12x plus 27. As you can see, this guy here, the result here is not the same as this guy. It's different. This is plus 17 at the end. This is plus 27 at the end. Okay? So you have to do things in order. All right? Example number 7. Graph, I think it's a figure 1.78. Determine the graph of the composite function by showing the effect of the sequence of transformations. So we're starting from so in this one, we're gonna start from y is equal to f of x, and we're gonna end up with y is equal to 2x, 2f of x, x plus 1 minus 3x, plus 1 minus 3. Okay? So, when I move the 3 over, I get y plus 3 is equal to 2f of x plus 1. Okay, so if I start with this guy, okay, what's the first transformation I can make? I'm going to go ahead and in the x to the left, 1 to the left. I'm going to shift x to 1 to the left, right? So I'm going to go in the x direction. I'm going to the left 1, okay? So I'm going to go from here, it's going to become that guy, right? And then in the y direction, what am I going to do? In the y direction, I'm going to go down 3. So what do I have? I'm going to have y plus 3 is equal to f of x plus 1, right? Now I'm going to go ahead and divide this by 2. That doesn't make sense, right? We can't do this, right? So if I do this, what happens, right? If I do this, okay, I'm not, so if I had this and I want to translate this, if I want to do a vertical stretch by 2, I would go like that. Okay, which is no good, right? Because then I would go minus 3, then I have to multiply that by 2 and I have minus 6, right? So what do I have to do first? I have to do the vertical stretch first. If I do the vertical stretch, okay, vertical stretch by 2, this is what I get, which gives me what? Y is equal to 2 f of x plus 1, right? Now I can go ahead and do the down 3, right? Now I do the, from here, this is what I had, and I'm going to go move this guy over here. Now I'm going to do the down y by 3, right? In the y direction, I'm going to go down 3. Right, so where y is, I'm going to put y plus 3. Y plus 3, 2 f of x plus 1, right? This is what I get. Now I move the 3 over, negative 3. And is this what I'm supposed to get at the end? Right? Okay. Now you see, again, the important part here is understanding why I had to do the vertical stretch by 2 first. And then I do the vertical shifting down of 3. Okay? So, blah, 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 blah. Okay, all right, whatever. Okay, all right, we're good. All right, any questions there? All right, let's go ahead and continue working on the homework then.